We now come to an exercise which is not strictly speaking a ground rent exercise. It actually has to do more with land value and the estimation of land value directly from a particular strategy with land. In some cases you don't have an established land market. This might be the case, for instance, where land is not zoned for a land use that you have in mind, and you're considering what possible benefit it might have, this new land use, and perhaps what level of resources you might be thinking about putting into getting permission or the authority to realise that highest and best use. And so you might own a paddock next to a town, and you want to see what it would be worth to you if it could be developed, and if it's really worth enough to you, you might then embark on some activity, maybe lobbying town planners or local government or state government or what have you, in order to get permission to do that. And I've seen lots of domestic situations, say when you have somebody who has a bit of industrial land adjacent to some residential land, or it could be commercial land next to residential, and they would like to extend the commercial area just that little bit further so that the residential space becomes commercial, therefore more valuable, this sort of thing. And so you don't actually have a market at all. Now, there are a number of possibilities when you're doing this. You could do the ground rent situation that we looked at, especially in the second exercise, where you let a developer investor take the property from you, or at least use the property while you retain the rights to the land itself. You can simply sell it to a developer, or you could develop it and hold it. In other words, go from being a developer to a landlord yourself. Now, this last situation is not that uncommon, as organisations such as Stocklands occasionally use this strategy, and it's quite a sound strategy for regular developers. And so Stockland has a development arm, but they also have an investment arm, so they own a number of properties, for instance retailing, but also other usually specialist properties that they develop themselves and then lease and act as a developer. And a number of organisations that do this. So in the retirement area, there are a number of the larger operators who both develop and operate retirement facilities. Sometimes they develop them and sell them, sometimes they buy other people's, and so there's a bit of flexibility in how you do it. And so this type of analysis has a lot of applications. It has a particular application, oddly enough, with customary people. And the reason for that is that customary property rights are perpetual with their owners. And so if you have a tribe who owns a tract of land or has customary property rights over it, they don't understand it as ownership. They understand it as a permanent, perpetual relationship. And so for them, the idea of selling their property to a developer is simply not something they can conceive of, they can accept. And so the only two options they have is either to do the ground rent situation, where they lease the land to someone who's going to build something on it and operate it, or they can do the development hold themselves. And there are a number of examples of develop and hold over indigenous property done by, I think, the shrewder customary groups. There's an example on the north coast of New South Wales of a shopping centre. There are a number in the Northern Territory and other parts of Australia to do with tourism. And so this type of analysis is particularly appropriate for indigenous people, especially indigenous people who understand the dimensions and the opportunities that come from their particular approach to property. Okay, so the situation is a landowner intends to develop his property and lease it once completed. In other words, not actually lose the control of the land itself, but also the development itself. So it's a little bit of a difference. It's actually a bridge between the ground rent situation that we did in the second exercise and the development, the true development world that we're going to be exploring in the next module. And so the question we want to answer is, what's the financial value to the owner? Now this is I won't say a code word, but it basically means what is the land value to the owner, because it says I own this land, say Indigenous people, I've owned it forever, and what is it worth in dollar terms today to me in terms of this particular development option. And so really while we're talking about financial value, we actually mean land value. A number of the ideas that we're going to go through in this exercise especially are things for more interested students to really ponder over, because it actually takes you to a deeper level in understanding the way that property works and how to understand the values of property rights. Okay, now the assumptions we're going to make. We're going to assume that construction is 100% financed using capital interest. Now, capitalised interest is something we're going to be looking at when we talk about development in the next module, so we don't need to worry about too much there. What we're saying here is that for simplicity's sake, we're going to assume that we have a single number for the whole of the construction costs, including anything to do with financing and anything else for that matter. So it's just a total blanket single figure, and importantly that single figure is going to be expressed in dollar values at the end of the construction period, which is simultaneously the beginning of the investment period, the period where it's going to be leased out. And so again, that just simplifies it. We're going to be using this $15 million here. Now, if you were doing an actual case of this, you might want to do a lot of work behind getting to this number. But the important thing is it's a single number, what makes it easy to work with, and it's expressed at the end of the development period. Okay, we're going to ignore escalation on construction costs over the development period. Again, that's just to keep this number here easy so that we can look at the real mechanics of this particular model rather than get lost in development and construction financing. Lastly, we're going to assume annual loan payments and rents are received annually in arrears. Again, that's a simplification to make our calculations a little bit simpler here. In a real situation, you may want to maybe work it out to annually in arrears, and then using present value functions or payment functions or what have you, take those annual cash flows and then work out what they look like in monthly or even weekly terms. Oh, one other point that we're going to be including here is that because we're assuming that the development is 100% debt financed, at the end of the development period we're going to be still owning the property, so we don't get money just coming out of the air. What we're going to do is then turn that development loan into an investment loan, and we're going to pay it off as a credit foncia loan. The reason we're going to do that is that we want to get to the end of the investment period, the end of the economic life of the building, with no debt. And so whereas if we were a regular property investor, we'd only be thinking of an interest-only loan, here we're going to have a principal and interest loan, which is what credit foncia means, and that means that over the 40 years of operating the building until we get to the end of its economic life, we're going to be paying off the principal interest. And so when it comes time to demolish the building or do a major refurb or whatever we're going to do, we have no debt. That is a very wise matching of the incomes from the investment with the costs of the investment, the financial costs. And so we're going to make that assumption. We go to that credit foncia loan. Now, the data in here will look fairly familiar. Most of these items we've seen before, with the exception of the fact that in this second exercise, where we're looking at development, we simply looked at a property rental at the end of the development period, because that was something that the investor was going to look after. Here, what you'd get from the market more often is a rental in terms of a rate per square metre, which is what you can find in the market. It's the currency of commercial rents, and to that we add the net lettable area, how big the property is, how many square metres can we actually lease out. And so this little complication here is put in just to give you a bit of a flavour for what it's like from a developer's point of view or someone doing this type of analysis, because the $300 per square metre comes from the market, the 4,000 square metres comes from the building plans, and you simply multiply them together. The rest of it, interest rate, makes sense, and so on. We're applying a rather optimistic property growth here, but again, that could suit a particular market. The numbers aren't really that important with the model, because once we get the model done, of course, we can change the data to suit actual situations. And by the way, this model is sufficiently detailed to be used in practice for this type of a problem. So as you go on, make sure you don't lose it. Okay, what are we going to do here? The model begins by working out what loan payments the landowner must make through the investment period. We have $15 million of debt. To fund that, we're going to take a loan. To work out the loan repayments, we use the payment function, and the rate here is the interest rate, number of periods. We're going to match that to the economic life of the building. The PV, in other words the loan principal in this case, we'll put a minus sign to get our sign convention working, and it's the $15 million that we've just spent on building the building in the first place. So that means that year by year, over the 40 years of operating the building, we're going to be paying $1.257 million in interest payments. Now, from the perspective of the landowner, that regular annual cost can be considered as a present value figure, and we're going to work out what the financial value of that is, or the financial cost of that is, to the landowner. We do that by using the PV function, very similar to what we've done before, only here the rate is not going to be the interest rate, it's going to be the landowner's discount rate. You might want to give a thought to why that is. Certainly important to understand why it is. It has to do with the fact that from the landowner's point of view, it doesn't really matter whether it's a tax or a interest payment, or I don't know, the cost of operating the air conditioning, whatever it is. It's simply a number of dollars each year that the landowner has to pay. So that's a set of cash flows, and the landowner is going to work out what the present value cost of that is. And so again, we've got the rate as a discount rate to the landowner, the term is the same, the 40 years, the payment now is going to be the loan repayment. I'll put in a minus again to get our sign convention sorted out. And so that means that the present value of the loan repayments, present value of the loan, if you like, to the landowner is $10.369 million. Now, initially we can make a little observation here. Why is the $15 million, how did the $15 million of present value for the construction costs turn into $10 million? That's simply the profit that the landowner is making by using somebody else's money at a cost which is less than their own discount rate. And so the difference between the 15 million and the 10.37 million is because of the difference between 12% and 8%. I'll let you think that through, but it's important that you understand what's going on there. It's a very important financial relationship, and when you understand it, you'll discover it's in fact very, very simple. Okay, that value is expressed in the landowner's dollars, if you like, at the end of the development period. How do we bring that back to today? Because the development period is 30 months. We need to do a present value there. Now, I tend to do present value calculations longhand. I don't use the Excel function, but you're most welcome to use a Excel function. It's just that by doing it longhand, it helps me to remember the mathematics, and I think it would help you too if you did it, because it gives you that sort of currency of understanding, which is kind of keeps you on the ball a little bit. And even in 10, 20, 30 years time, you'll still be doing these calculations, and it's still important that you understand what's going on. However, you can use their built-in functions as well if you like. When we present value something, we divide it by 1 plus I, 1 plus the discount rate, raised to the n. And so in this case that's 30 months expressed in years, so we divide the 30 months by 12, close brackets. That's the longhand version of that. You're most welcome to do the Excel PV function, remember the double commas to get the parameters in the right place, but you should end up with the same number, 7.811. What that means is the $15 million of construction costs that the landowner is going to see at month 30, by the time they go through the financing and so on, is only actually hurting them to the extent of $7.8 million in today's dollars to the landowner. And so it's quite profitable simply to do that from the landowner's point of view today, regardless of what else they do. Okay, right now we've got an empty building. That's the landowner basically has sunk $7.8 million of his present value funds into. We need some revenues to make that expenditure worthwhile. Let's look at the rents now. The rental rate at the start of the lease. What we want to do is take the rental rate, $300 per square metre, and escalate it so that we get its value in 30 months' time. And that's a future value. And again, I'm going to do this longhand, but also you can use the FV function in Excel. Most welcome to do that if you want. I'm going to multiply $300 by 1 plus I to the n, 1 plus. Now here, the escalation is going to be escalated at the property growth rate. Now you'll notice that in the last few calculations we've used 3 rates. We've used the interest rate, the landowner's discount rate, and now we're using the property growth rate, all using exactly the same mathematics, and really more or less over the same terms very often. What's going on here? It really shows us that ultimately if we understand applying this 1 plus I to the n, you'll find that's the multiplication factor that is used in most of your financial maths, but it's important to know whether you're multiplying or dividing it, and also what the rate is. And this is a lovely exercise because it gets us to use these different rates in very quick succession, and so it helps you to be a bit sharp in understanding which one to use when. Okay, that means that the $300 per square metre of rental value today, in 30 months' time, that's going to escalate up to $339. That's fantastic. To get the total rental value at the start of the lease, we take the 4,000 square metres of net lettable area which has just been built, we multiply that by the rental value per square metre at the beginning of the lease period, and that will give us $1.35 million per year. That's pretty fantastic. It means that the landowner now is earning $1.35 million per year. They're paying out $1.25 in loan interest repayments, or interest and principal repayments, and so they're making a bit of a profit out of it. From that we can work out the developed property value at the start of the lease. We're going to do that by capitalising the rental. We're going to consider this, by the way, as a net rental. Again, in a real case you might want to put more colour into that. We're going to take the rental, we're going to divide that by the commercial yield. So that means the property is now worth $15.063 million. That's at the point of the lease start. We're going to present value that back, and I'll do the shorthand way just to demonstrate how it works as well. The rate is going to be the developer's rate. The number of periods is the 30 divided by 12. 2 commas to get to the future value. Put in a minus, do that. That gives us $11.346 million. And so the developed property value, present value, to the landowner, because it's worked out in terms of their rate of return, is 11.36. Okay, now we can work out what the net financial value, in other words, what's the land worth out of all that. What we have is the value of the property in its present value form. From that, we can subtract the value of the loan in present value time to the landowner, and that gives us a land value of $3.5 million. Now again, you see that might have been a bit of scrub a little while ago. Suddenly you've built, let's say, a tourist facility, again out in the scrub somewhere, an unlikely place to build a complex building. But what that's really done is taken that bit of scrub from being worth just about nothing, out in the never never somewhere, and now it's the effective value of $3.5 million. And so that looks pretty impressive. Now what the landowner can do is say, well, if I develop and hold myself, the land is worth $3.5 million to me. If a developer comes along and offers them something different, well, they can sort of think about whether that's attractive or whether they want to give it to somebody else as a ground lease. Again, they've got this develop and hold situation as the reference, as their base level, if you like, to compare it. Now the elegant thing about this kind of modelling is that it gives you that land value in the absence of a market. Very, very useful for, say, comparing your options, working out your highest and best use, and that sort of thing. Now with this exercise, you'll notice that a number of these use the present value functions. Some of them you can do with any calculator, some of them require a financial calculator. I do recommend that you check this using a financial calculator, because I can't emphasize enough that by the time you get to the final exam, you'll need to be able to use a financial calculator to do these type of equations. So practice now and practice a lot, and that will help you. It also helps you understand what's going on, and really the understanding is as important as being able to press the buttons on your calculator or your computer. So give it the time, think through what we've done here, and that will enable you now to be able to use these skills, if you like, as a little toolbox to attack other problems, to maybe make more complex problems, or to respond to questions that clients might have that might be also not what you expect a valuer to actually do, but what they're called upon from time to time to give expert advice on.